Hey everybody, today we're going to do some more factoring. Specifically, our answers today when we factor will be considered to be irrational. So we're going to find irrational zeros or solutions today. An irrational number is just simply a number that cannot be written as a fraction, and generally we consider that to be most commonly a square root of a number that isn't a perfect square. Like some examples there, square root of 5, square root of 3, or the cube root of something that doesn't work out. There's lots of other examples, but for us, that's primarily what it's going to look like. So it says to find all the zeros by factoring. All the factoring rules apply basically by the fact that you know that they're irrational. We're just giving you a little prediction as to what the answers will look like. This particular problem here has nothing in common. In order to get x to the fourth, we use x squared and x squared. We want to multiply to get 18. So if we multiply to get 18, that could be 1 times 18. Of course, when we add that up, that's not going to work. 2 times 9, that's not going to work. 3 times 6. So it's probably 3 times 6, because when you add 3 and 6, you'll get a 9. But to make it a negative 9, we'll make them both negative. Set each factor equal to 0. And then let's solve this. So when you take the square root, remember, you always use a plus or minus, and then you just simplify the radical if possible. You don't write a decimal. We want to leave it as that radical, an irrational number. So here we get x squared equals 3, take the square root, and x is plus or minus the square root of 3. In the second problem, at first glance, at least for me, I thought they had something in common, but this 33 kind of makes it not work. So again, we're trying to go from 8 to 33. So we're going to stick with our large numbers. So I'm going to go with 4x squared and 1x squared. So just to try to make the numbers as big as possible. And with 8, obviously we do 4 times 2 or 8 times 1. Now with this, we cannot make any predictions as to being able to add to get to 33 because of the 4. So I'm going to go with the big number again. I'm going to stick with 8 and 1. So this is truly just guess and check. Outside we get 32, and of course that's x squared. Inside we get another x squared. So we can get 33 with that, and of course we want them both to be negative. So that works, because then we get a positive 8 when we multiply. So here we get 4x squared minus 1 equals 0, and x squared minus 8 equals 0. When you divide by 4, we get x squared equals 1/4. Taking the square root of a fraction, be sure to take the square root of the top and the bottom both. So for this one, I'm going to put the answers over here. We get x equals plus or minus 1/2. That is not irrational, because that obviously is a fraction. For the second part, we get x squared equals 8. When you take the square root of 8, we'll break it down into its prime factors. 2 times 4, and 4 is 2 times 2. When you make a factor tree, if you have 2 that match, you can bring that out. So we're going to have a 2 on the outside. This 2 has no match, so it stays under the radical. And of course, when you take the square root, plus or minus, then we'd have 2 radical 2. So just that piece is the irrational piece. I'm not saying every answer is going to be irrational, but that is our focus for today. For number 3, we have 4 terms. It's going to be grouping. The first 2 have x squared in common, gives you with 2x plus 5. Now the second 2, as we break this up, starts with a negative, so you're going to want to take that negative out. 24 and 60, that's a negative 12. And you can kind of guess, because we were trying to get to the 2, so I was just trying to think, how can I get what's 24 divided by 2? So that's how I came up with the 12 right away. So this will be 2x plus 5. And now you can see they have the 2x plus 5 in common, so those are gone, and we're left with the x squared minus 12. So 2x plus 5 equals 0, x squared minus 12 equals 0. Here we get 2x equals negative 5, and then of course x is equal to negative 5 over 2. When we get this 12 on the other side, we have to take the square root. So 12 It doesn't matter where you start your factor tree. Starting with 1 times 12 won't really get you very far, but you could start there. I'm going to start with 2 times 6. 6 is 2 times 3. So we have a pair of 2's. So that is going to come out, and then the 3 stays under the radical. So plus or minus 2 radical 3 and negative 5 halves. Let's do another grouping problem. This one is going to be a tiny bit different once we get to the solutions. So in common for the first two is a 3x squared, looks like, and then we're left with x minus 5. Again, the second pair starts with a negative, so we're going to take out a negative 4. We're left with x minus 5. So now we group this up again, this x minus 5, they have this in common, and we're left with 3x squared minus 4. So here we just get x equals 5. That was fast. Now this one is going to take a minute. 3x squared equals 4. Then we divide by 3. So now we have x squared equals 4/3. This is the first time we've had a fraction that doesn't really simplify super fast. So we get x equals plus or minus. This 2 is good. It's the radical 3 that isn't. Now as you know, you're not allowed to have a radical in the bottom of a fraction. So you have to multiply the top and bottom by radical 3. So we get x equals plus or minus, go straight across, 2 radical 3. And the whole reason we did this was to make this radical 3 times radical 3 turns into a plain old 3. So that's what happens when you have a radical in the bottom. You have to multiply it by itself because you can't leave it like that. Now to kind of tie in on what we just did with the synthetic division from the other day, here they're giving us a place to start, because if you look at this problem right here, that's a lot of terms. It's not factored by grouping. There's no greatest common factor. So basically they're saying, hey, it's probably not factorable, so we're going to give you a head start. So they tell you that x minus 4 is a factor, which means 4 is the root, and we're going to use synthetic division. Writing down all of the coefficients. We bring down the 1. Again, we're going to multiply 4 times 1. It's going to go there. And you always add in through here. Then we start the process over. Now you're going to do 4 times 5. And it's going to get pushed there. So 4 times 5 is 20. And of course we add. So that's a negative 3. 4 times negative 3 is a negative 12. This is a negative 3 up here because of, look at my problem, I forgot my negative sign. And so negative 3 plus a negative 12 is a negative 15. And 4 times negative 15 is a negative 60, and we get the 0. I got nervous there because I didn't think it was going to work. So let's rewrite this. The depressed polynomial, the original polynomial was x to the 4th. So that means this one will be x to the 3rd. When you write this polynomial, every time you come up with another term, so the next term is 5, that's going to be an x squared. Then we have a minus 3. You just take it down 1 every time you move to the right. And of course, this is where the equal sign goes. Now we have 4 terms, and it does look like we could factor it by grouping. It kind of feels a little bit like number 4. They have an x squared in common. We're left with x plus 5. This has a negative 3 in common. We're left with x plus 5. So now we have x plus 5 times x squared minus 3. So we get x plus 5 equals 0. X squared minus 3 equals 0. So this is x equals negative 5. And this would be, of course, x squared equals 3. And we'll take the square root. Square root plus or minus always, and then the square root of 3. So it said to find all of the real zeros. Well, don't forget about this one. It's a little bit of a trick. And you think, well, they gave that to me, but it's still a 0. So if the x minus 4 is a factor, set that equal to 0. So we get x equals 4, x equals negative 5, and plus or minus radical 3. Because we have a degree of 4, we should have 4 answers, and we do. So one more time with this synthetic division. Again, kind of a good review from the other day if you didn't catch on to it, or if you didn't watch the video. This one is going to have an even different ending. So again, it turns out doesn't look like it's factorable by grouping. So they give us the root, so we'll start with the -3. Coefficients, 1, -5, another -5, except I don't know what I'm looking at. That's not true. Sorry. There's only one -5, as you can see, -29 and -15. So we'll bring down this 1 and start to multiply. Again, remember, multiply, push it forward. So this will be a -3. We always add, so that's a -8. Start over, box times the bottom number, so that's going to be a +24. Always add, so that's a -5, +15, 0. So it was supposed to work. I'm glad it did. So this is x squared minus 8x minus 5. And now we're trying to multiply to get to 5 and add to get to 8. That's not possible, but the directions say we have to find all of the zeros. And now we know we can have radicals, so quadratic formula, which is the opposite of b, plus or minus the square root of b squared minus 4ac. All of that's over 2a. Your first term is a, this term is b, this term is c. So we're going to have the opposite of b. So -8, we want to take the opposite of that. Underneath here, don't write 8 squared. That's just adding to your arithmetic. I'm just going to go ahead and square it. Then the 4 is from the formula. A is 1. C is a -5. You take the sign as well. And then the bottom we have 2 times 1. This turns into 64 plus 20 under the radical. So now we have 8 plus or minus the square root of 84 over 2. Don't start crossing stuff off until we've broken down this radical. 84, I'm going to have to go up here. Yikes. This is 2 times 42, which is 2 times 21, and 21 is 3 times 7, so there's no pair. So we have 2 radical 21. So we get 8 plus or minus 2 radical 21 over 2. Now at this point, since you have all 3 of these numbers that can be reduced, you reduce all 3 of them at the same time. It takes 3. So we're left with, got to slide over, this is a long one, so we have x equals 4 plus or minus radical 21, because this is a 1 and this is a 1. You can write those ones if you want to, but we know they don't have any meaning. And then also, don't forget this one, the one they gave you. So if x plus 3 equals 0, then we also get x equals -3. So here are the 3 answers. So with the addition of being able to use square roots, of course, now we're going to maybe need the quadratic formula. So make sure you're kind of prepared for that. It doesn't happen often, but it will happen. Your assignment's on the back, and please, if you get stuck, just stop and bring all your questions back to class or stop in at office hours, and I will be happy to help you.